Hello and welcome to today's chemistry class for beginners. Today's class is going to be a very interesting one because we'll be dealing with calculations when we talk about balancing of chemical equations. But before we go into that, I would like you to please like, share and comment on this page in order to boost what we do. In this topic, there is the key thing which we do, which is the main essence of balancing of chemical equations. And the essence is to count the number of each atom of every element on the left-hand side of the equation and ensure that it is the same on the right-hand side of the equation. But this came about due to the law of conservation of mass, which states that the mass of reactants must be equal to the mass of the products at the end of the reaction. That means nothing should get lost at the end. I would start by using this example, H2SO4 plus NaOH. That will give us Na2SO4 plus H2O. This equation in front of you is not balanced. So we will try to balance it now to use it as an example to learn. Take a good look at the slide in front of you. You can write it down on a piece of paper. You would notice that we have hydrogen, sulfur, oxygen, and sodium written to your left, while the total on the left-hand side is written at the top and total on the right-hand side at the top also. Now, hydrogen has 2 plus 1 on the left-hand side to give us 3 atoms altogether, while on the right-hand side there are 2 of them. Sulfur has 1 on each side, while oxygen has 4 plus 1 to give us 5 on the left-hand side. On the right-hand side, it also has the same thing, 4 plus 1 to give us 5, while sodium has only 1 on the left-hand side, and of course 2 on the right-hand side. Now go back to hydrogen. You will see that the 2 plus 1, meaning 2 hydrogen came from the H2SO4, while the other one came from the NaOH, that H at the end. So the 2 plus this 1 is what is giving us the 3 hydrogen on this side, while on the other side we have only 2 hydrogens, which are the ones attached to the H2O. If you go and check for sulfur, you see we have roughly the same thing, S and S, only once on both sides. Go and check for oxygen, you will see we have H2SO4, O4, that 4 is the first 4 you are seeing, while on the NaOH, that O is the one you are seeing, they mean 4 plus 1 to make it 5. Go to the other side, you have roughly the same thing also, while for sodium, it is 1 on this side, meaning NaOH, that Na, while on the other side, you have Na2SO4, that Na2, that 2 there is what is bringing about the 2 sodium on the right hand side. Please feel free to copy this down, play back, and make sure you understand this slide very well. Now look at this next slide. You will notice we have on the right hand side some red and green buttons. The red buttons indicates that that line is not balanced because 3 and 2 are not the same thing, while the one that has green, you can see 1 and 1, it means sulfur is balanced. 5 and 5, it means oxygen is balanced, while 1 and 2, you can see a red there showing that sodium is not balanced. Please be very slow and deliberate about this. Go back and ensure that you check this thing before you continue. If not, you might not understand every other thing that will be happening in front. So now, going forward, you will discover that those ones that are not balanced are the ones we are going to target now to try and balance them, but be informed. In trying to balance them, we might distort the ones that are already balanced, but you will see how it works. Now, this is the main equation, which you can also cross-check now to see with the ones behind, what we have just done behind. Cross-check to count the number of hydrogen, oxygen, sulfur, and sodium there. Once they are complete, it's now time to pay very good attention. Please pay good attention. This is where the explanation proper is. Pay good attention. Now let's start with hydrogen. Remember I told you that 2 plus 1, meaning 2 hydrogens came from H2SO4, then the 1 hydrogen came from NaOH. You normally target the particular one that is the odd number, which is 1. So we go to sodium, that's NaOH, and then multiply that 1 by 2. When we multiply it, add it to the other 2 from the other hydrogen, that will give us 4. Then we go back to the other side, that's the right hand side, where we have H2O. We multiply the 2 that is there by 2 to give us 4. You will see it has become 4, 4. We have balanced that one. When we go to sodium, it is already balanced, so we still leave it. We come to oxygen. You will notice I told you again, the 4 oxygens came from H2SO4. So we are going to the other oxygen that is with NaOH. That is where we're going to multiply by 2. When we multiply by 2 and add 1 to it, you will discover that we are going to have 6 oxygens altogether. Go to the other side. We are going to repeat the same thing, and we are going to have another 6 oxygens. Now, if you go to sodium, I said 1 times, and I said take note of here. Something has been distorted, that's why I'm saying so. But when we add what I'm doing there, we're going to have 2 in the end, so that we're going to have 2 also at this end. That's at the right hand side. Now, for the sodium part where I said take note, go back and see the time we tried to balance oxygen. You will notice we put 2 there. The 2 was multiplying through everybody that is in that NaOH, meaning that the sodium has already been multiplied by 2. So if you because it has already been multiplied by 2, it has become 2. If you check it with the other 2 on the other side, it is already balanced. The trick here is to target the odd numbers and multiply them to make them even. In doing so, you will see that you get your equation balanced easier and faster. If you have reached this slide, it is time to also pause, calm down, and cross-check everything we have been doing down till this point. Check out the underlined aspect in red, the one I underlined with red. You will notice that is where all the mathematical gymnastics took place. The 2 that were added in front is what I told you was multiplying sodium, oxygen, and hydrogen. So sodium there is now 2, oxygen is now 2, hydrogen itself is also now 2. Then go back to the right hand side, that 2H2O. You will see the 2 is multiplying H2, meaning the H2 is now, the 2 there is now 4, and then the oxygen is also now 2. All the things we did on that board is exactly what is playing out here. The balancing that we have done is simply adding 2 to NaOH and then 2 to H2O. If you count each atom present here now, you will discover that they are all equal in number, both in the left hand side and on the right hand side. If at this point you do not understand anything, I suggest you go back and go and check again. It is not by rushing. Go back and go and cross-check from the beginning to ensure that you're able to count each element one after the other till you see that it is balanced. And of course, if you have questions, you should feel free to get to me or drop your comment in the comment box. I would at this point want to take a second example of roughly the same thing, but to show you something different that can happen during balancing of chemical equations. Take a look at this equation. CH2, C2H6 plus O6 to give us CO2 plus H2O. Now let's try and balance this. You would notice that on both sides, the number of the atoms of each of the elements is clearly not balanced. And I told you ab initio that we are going to have to count each one. Carbon, you can see we have 2 on the left hand side, 1 on the right hand side. 6 on the left hand side, 2 on the right hand side. Oxygen, 2 on the left hand side, 3 on the right hand side. But don't forget I told you that 2 plus 1, you know that 2 oxygens came from the CO2 and then 1 oxygen came from the H2O. So when you are multiplying, you will know exactly where to target and where you are going to multiply. I will still reiterate, do not rush this thing. It is calculation. You need to take your time. If it means you go back, you pause, do so, go back, pause, and make sure you see everything I am talking about here. Now, your guess will be as good as mine. That is, we will target carbon now. The side that has 1, we're going to multiply by 2. Hydrogen, you can see we have 6 and 2. The side that has 2, we're going to multiply by 3 so that it can become 6. And then, of course, for oxygen, the side that has 2 plus 1, we go for the 1 and we multiply that one by 2 in order to bring it up to an even number. Like I will always warn, please do not rush this topic. Calculations are not meant to be rushed. At the end of this, do you now discover that we have 2 greens and 1 red? The greens, of course, means they are balanced. The red is not balanced. Like in the first example, that place that is not balanced is where I said, hold on, something has happened. Now look at the main equation. You can see we have C2H6 plus O2. We have our arrow, then 2CO2 plus 3H2O. We have added that 2 and 3 on the right hand side. We have done nothing yet on the left hand side. That is because I want you to see clearly how we are going to make an adjustment now to make this equation balanced. If you go through, you will see that carbon is balanced, hydrogen is balanced, oxygen is the only odd man out that is not balanced, having 2 on the left hand side and then having what do you call this, 2 times 2 making it 4 plus 3 making it 7. You can see them underlined in blue. Now that 7, because it is an odd number, it will give you a challenge to try to balance. But there is a unique way we normally use to balance it. Now you go back to that 2 in the oxygen that's on the left hand side, which we left untouched. Multiplied by 3.5, you will see that we're going to have 7. That is 3.5. You see that we'll have 7. If this happens, you will see that we are all clear. This equation will now all be balanced. Carbon will be balanced, hydrogen will be balanced, oxygen will be balanced. But the challenge would be, which would be unique to a beginner, is seeing that 3.5 or 3.5. It will sound strange. It is really not strange in chemistry. At this point, you can choose to leave your equation this way and you say you have finished your work, you have balanced it. But just for the sake of, to avoid confusing you being a learner, there is one more step which you are officially allowed to take in order to correct any anomaly that you are seeing. Now, but we transfer this to the main board and see that the whole right hand side has become green now. Now that we see green mark against each dot, each line, it simply tells us that each of the equations are now balanced. That means we can go ahead to input these figures beside each of the compounds in the main equation. So watch and see how we do that now. So in the next slide, we are now trying to remove that fraction, that 3.5. And the only way we do to remove it is to multiply the whole equation by 2. Now, just check oxygen alone, only that line, that's the one we are multiplying by 2. If we do so, you will see that 3.5 will become 7. At this point, every other thing will now become green, meaning that they are now balanced. But we will still have an issue because we are multiplying the whole equation by 2. We're going to have something very unique, which I know you're going to see in the next slide now. Now look at this. This is the original slide before we multiply by 2. You will notice the underlined part is the 3.5 part that balances oxygen. So that is what we want to try and remove now. When we multiply the whole equation by 2. Take a look at the next slide now. You will see that we have now multiplied everything by 2. 2 has now appeared in front of C2H6. Now 3.5 has now become 7. 2 that was in front of CO2 has now become 4. 3 that was in front of H2O has now become 6. At this point, this equation is balanced well enough. Count all the elements. You will see that they are all the same on all sides. Thank you for watching. Hope to see you in the next class. But please like, share and comment in the comment section.